Have you ever wondered why the tiniest particles in the universe behave in ways that defy our everyday logic? Welcome to the mind-bending world of quantum physics, a realm where the rules of the game are drastically different. This is the science of the very small, the world of particles that are so tiny they're measured in units called quarks. Quantum physics is not just a theory or a branch of study, it's the very foundation that drives our understanding of the microscopic universe. It's the key to unlocking the secrets of atoms, the building blocks of everything you see around you, and even things you can't see, like air and energy. Imagine a billiard table with balls moving around, colliding, bouncing off the edges. That's classical physics, the physics of the macroscopic world, the physics we're all familiar with. It follows a set of rules and principles that make sense to us. If we know the initial positions and velocities of the balls, we can predict their future movements. Now imagine if the billiard balls could be in two places at once, or morph into waves when no one is watching, or get entangled so that the state of one ball instantly affects the other, no matter how far apart they are. That's quantum physics, a realm where particles can behave in ways that are outright bizarre and counterintuitive to our everyday experience. But why does it matter? Well, without quantum physics, our modern world wouldn't exist as we know it. Your smartphone, the GPS system, lasers, even the sun that gives us light and warmth all work on the principles of quantum physics. The most fascinating aspect of quantum physics, however, is the principle of superposition. Imagine a coin spinning in the air. It's neither heads nor tails, but both at the same time. Quantum particles can exist in multiple states simultaneously, just like that spinning coin. At the heart of quantum physics lies the peculiar principle of superposition, where things can exist in multiple states simultaneously. Think about flipping a coin. It's either heads or tails, right? Now, what if I told you in the quantum world it could be both at the same time? Welcome to the weird and wonderful world of superposition. This is a realm where traditional rules of reality are tossed out the window and replaced with something altogether more peculiar. Let's take a stroll down memory lane to the early 20th century. The physicist Erwin Schrödinger devised a thought experiment that has since become a staple of popular science. He asked us to imagine a cat inside a sealed box. In this box, there's a tiny bit of radioactive substance that may or may not emit a particle within a certain time frame. If it does, it triggers a mechanism that releases a deadly poison, killing the cat. If it doesn't, the cat remains alive. Now, according to the rules of quantum mechanics, before we open the box to check, the radioactive substance is in a superposition of states. It has both decayed and not decayed. And because the cat's fate is tied to this, the cat too is in a superposition of states. It's both alive and dead. This, my friends, is the heart of superposition. Until we observe the cat, it exists in all possible states simultaneously. Only when we open the box, when we make the observation, does the cat become definitively alive or dead. But don't get too worried about the cat. This is a thought experiment after all. The real purpose is to illustrate the strange reality that quantum particles can exist in multiple states at the same time. It's a concept that shakes our everyday understanding of reality to its core. Bizarre, isn't it? But hold on, the quantum world gets even stranger with entanglement. What if two particles, no matter how far apart, could affect each other instantaneously? Sounds like science fiction, but it's not. Welcome to the mind-bending world of quantum entanglement. To understand this, let's imagine we have two particles. Now, these particles aren't just any particles, they're entangled. This means they're mysteriously linked in a way that transcends the ordinary rules of space and time. In this entangled state, the properties of these particles become intertwined. Let's say we measure one of these particles and find it spinning clockwise. At the exact same moment, its entangled partner, no matter how far away, will be spinning counterclockwise. This change happens instantaneously, faster than the speed of light, defying the laws of classical physics. You might be thinking, well, maybe they were always spinning in opposite directions. But here's the catch. Until we measure them, these particles exist in a state of superposition, spinning both clockwise and counterclockwise at the same time. It's only when we observe one that they both choose a definitive state. So, how does this happen? To be honest, we're not entirely sure. Some propose that there's some kind of unseen, faster-than-light connection between the particles. Some suggest that all possibilities exist in parallel universes, and when we measure a particle, we're just picking one of those universes, and some say, well, that's just how the quantum world works. What we do know is that quantum entanglement is real. It's been tested, observed, and utilized in technology like quantum computers and quantum encryption. It challenges our understanding of the universe, pushing the boundaries of what we thought was possible. So, next time you're looking up at the stars, remember, there's a whole lot of spooky action going on up there. And down here too, at the quantum level, where particles are dancing in a mysterious, entangled ballet, invisibly connected across vast distances. In the words of Albert Einstein, this is spooky action at a distance. So, how does all this quantum weirdness affect you in your day-to-day life? Imagine a world without computers. It's difficult, right? The very technology we rely on for work, communication, and entertainment is a direct product of quantum physics. The transistors in your computer, the tiny switches that allow it to process information, operate based on quantum principles. In fact, without understanding the quantum effect known as tunneling, we wouldn't have been able to create these transistors in the first place. But it doesn't stop there. Have you ever wondered how your GPS always knows exactly where you are? Quantum physics is at play here too. Timekeeping is a crucial element of GPS technology, and the most accurate timekeepers we have are atomic clocks, which are based on the vibrations of atoms, a truly quantum phenomenon. Moving away from technology, quantum physics also has significant implications in the field of medicine. Medical imaging techniques such as MRI scans rely on quantum physics. These scans work by manipulating the spins of atomic nuclei, another concept that springs from quantum theory. And let's not forget about the sun, that giant ball of gas that gives life to our planet. The process that powers the sun, nuclear fusion, is fundamentally a quantum process. Without quantum physics, we wouldn't understand how the sun works, and we certainly wouldn't be able to harness its energy through solar panels. It's also worth noting that the quantum world is still full of mysteries. There's plenty we don't understand yet, but that's what makes it so exciting. As our understanding of quantum physics grows, so too will its impact on our lives. The quantum computers of the future could revolutionize everything from drug discovery to climate modeling. So, you see, quantum physics is not just a bizarre theory, it's integral to our daily lives. As strange as it seems, quantum physics is shaping our future. This might sound like a concept straight out of a science fiction novel, but the reality is, quantum physics is already driving numerous advancements in technology, and its potential to revolutionize our world is simply astounding. Let's start with quantum computing. Traditional computers use bits to process information, which are either in a state of 0 or 1. Quantum computers, on the other hand, operate with quantum bits or qubits. These qubits can exist in a state of 0, 1, or both simultaneously, thanks to the principle of superposition we discussed earlier. This allows quantum computers to process vast amounts of information at speeds that are currently unimaginable with traditional computing. Just imagine, complex problems that would take our current supercomputers centuries to solve could potentially be solved by quantum computers in a matter of seconds. From modeling complex chemical reactions to optimizing global supply chains, the applications are endless. Another fascinating application of quantum physics is quantum teleportation. Now, don't get too excited. We're not talking about beaming people up like in Star Trek, at least not yet. Quantum teleportation involves transferring the state of a quantum particle from one location to another without any physical movement of the particle itself. It's like transmitting a fax, but at a quantum level. This could revolutionize the field of communication, making it more secure and much faster. Now, these technologies are still in their infancy, but the progress we've made so far is inspiring. Quantum physics is not just about understanding the fundamental nature of our universe. It's about harnessing that understanding to create technologies that can change our world. As we continue to explore this strange and wonderful quantum realm, we're bound to encounter more surprises, more mysteries, and more opportunities for innovation. The promise of quantum physics is immense, and we're just at the beginning of this exciting journey. In the quantum realm, the impossible becomes possible, and the future is truly now.